So the question is the following, that you have been given some n points on a circle, right, and every point is connected to each other by a cord, as you can see here, and you basically have to find the number of intersections that there are going to be. So when n is 4, we can see that the number of intersection is just 1. When n is 5, we can see that there are 1, 2, 3, 4, 5. So intersection is also 5. And it is also given that no 3 chords meet at a single point. So we can see that when n is 6, we can see that I is equal to 15, right? So you have to come up with a formula that if you have n points, how many intersections are there. So before I go ahead and show you the solution is actually pretty short. I encourage that you go ahead and try this on your own, because when I was working on this question, I came up with, well, frankly, a bad solution. But like a wise man once said, it is only after you come up with a bad solution that you can appreciate a good solution. So one thing you must realize, or rather, actually the only thing that you have to realize, is that if you have any n points, let's just draw some random points, and if everything is connected to each other and no 3 chords meet at a single place, the thing to realize is that if you let's label these p1, p2, p3, p5, p6, right? So if you look at these points, then you only have to focus on a combination of 4 points, because if you take any 4 points, let's take p1, p2, p3, p4, it is always the case, and this is easy to see why, that every 4 points will give you just one intersection. So this was also the case with n equals 4, and it is easy to see why, because when you draw diagonals like this, there is always one intersection. So for any 4 points have one intersection, and if you have n points, then you just need to look how many different combinations of 4 points are there. In other words, your answer is simply nc4, right? 4c4 was 1, we saw. 5c4 is 5, we saw. 6c4 is 15, we saw, and so on, right? So you just needed to focus on 4 points, and notice that different combinations, different 4 points combinations, each will give one intersection. So your answer is just simply nc4, and we are done.